I have gathered everything from the list of equipment required for experiment 1, starting with the test tube rack and several test tubes, and then there's a long list of reagents that I'm going to use. Now I think I've got everything off the trolley and everything's on the orange map. I'm going to sort them into the different tests now so that I know which reactants I'm going to need for each one. It tells me in the procedure to write down my observations as I'm going along. So I'll also make sure I have a pen or pencil so that I can take notes of what I see. Yep, so I had collected everything okay, and now I have put them into order. So this is for test 1, 2, 3, 4, 5, 6, 7 and 8. And now I'm ready to start doing my experiments and recording my observations. So experiment 1 says that at about 5 mils of iron 3 nitrate solution to about 10 mils of sodium hydroxide solution in a test tube and mix thoroughly. So we can see that we're adding less iron nitrate than the sodium hydroxide. Around about 5 mils. That'll be about 1 centimetre in the bottom of the test tube. Okay, so that's the iron 3 nitrate solution, and the proper procedure is to take the lid off and replace the lid of the first bottle before you open the second bottle so that you don't have any risks of cross-contamination. Now I'm going to add roughly double, and it looks to me like a chemical reaction has occurred. I can see a colour change. I can also see it looks like it's separating out. And now I think if I leave that for a little while, I'll end up with a sediment, and that shows that a precipitation reaction has occurred. For my observation, I will record that the iron nitrate solution was yellow and the sodium hydroxide was colourless, and then we formed an orangey precipitate. Now I'm ready to move on to test 2. In this case we're going to put 2 to 3 marble chips in a test tube. And add about 5 to 10 mils of 5 molar ethanoic acid, which is also sometimes called by its old name of acetic acid. So 5 to 10 mils. And you can see that bubbles are coming up off the calcium carbonate marble chips. Starting out slowly, but increasing in frequency. So that's my main observation from this reaction, is that a gas is being evolved. So I can write that down for test 2. Test 3. Place about 5 mils of 1 molar sulfuric acid in the test tube. Add 2 or 3 drops of phenolphthalein indicator. Now hopefully you remember that in acid, phenolphthalein is colourless. So I've added my indicator, but I can't really see anything. Now we are asked to add potassium hydroxide solution dropwise. Oh no, we're going to add about 8 mils to start with of potassium hydroxide. Well, I think I overshot the mark a little bit there. And yeah, I certainly did. I am nowhere near colourless. But here, if I want to remove the colour, now I'm going to add more drops of the sulfuric acid. You can see as it's added that we're losing the colour from the indicator. Yeah, now we're back to acidic, and I can try adding a drop of the potassium hydroxide now. Let's see what 1 drop of potassium hydroxide will do. Nothing. Nothing. It is hanging around, the colour is hanging around a little bit, but still won't remain. So this is very similar to what we do in a titration. That pink is hanging around for quite a bit longer now. So at this point we are very close to equivalence. And we aren't far away from, there we go, that 1 more drop was enough to then turn our solution basic. And I need to write down my observations there about the colour of the indicator, with those different volumes of the acid and the base. I'm going to skip test 4 at the moment because I need to do that in the fume cupboard and move on to test 5. We need a small piece of aluminium metal in the test tube. I have some aluminium here. I'll put that in the test tube. Add sufficient sodium chloride solution to just cover the piece of aluminium. So we don't actually need that much. The sodium chloride is acting as an electrolyte. It's not acting as a reactant. And about 10 mils of copper sulfate solution. Now, I can see some bubbles, but we can also see there's a lot of action on the edge of the aluminium, and it's changed colour. The edge of the aluminium is a reddish brown colour. And if we left this for long enough, we would see that reddish brown colour covering all surfaces of the aluminium. Let's go and have a look at our... we can see from our original test that that separation is continuing to occur. With a bit more time, it will end up with all of the solids at the base of the test tube. Okay, so what am I going to write down? I'm going to write down for test 5 that I've seen bubbles and I've seen reddish brown deposit on the aluminium. Test 6 says take 1 or 2 pieces of zinc. So, piece of zinc. Go for a bigger piece of zinc. Piece of zinc there, put it in the test tube. And add about 10 mils of 3 molar hydrochloric acid. And what we can see here, bubbles again. Hopefully you can see the bubbles. Test 7 is to put about 10 mils of lime water into a test tube, and we're going to use a drinking straw and blow into the lime water. So for lime water we have to decant, which means that we carefully pour off the top, trying to leave the sediment in the bottom of the bottle. Okay, so I've done reasonably well there because I can't see any solid in there. So now we're going to blow into the lime water. And the lime water has what we describe as turned milky. It's no longer colourless. Yes, a reaction has occurred there. Okay, so now we're up to test 8, and we need to use a small spatula. So I'm going to grab a spatula from the drawer and add some sodium chromate. Got some sodium chromate here. Add some sodium chromate to the test tube. And going to add some water to that. I'm using the wash bottle to make sure I don't touch anything with the end of the wash bottle. Just going to rinse that down. So it says water to a depth of 2 centimetres, and that's pretty close now. And dissolve the crystals. can see that and get that lovely yellow. Now we're going to add 5 ml of silver nitrate solution. For the silver nitrate, it is very important that this sits on our orange mat so that we don't end up accidentally staining the bench. So 5 ml is approximately 1 centimetre of silver nitrate. Okay, and I think we can very clearly see we formed a precipitate in this reaction as well. So, because we know that all nitrates are soluble, that must mean that the precipitate formed is silver chromate. The test tube actually feels cool as well. So that's telling me that that was endothermic. This reaction here with the zinc and the acid, that's exothermic, but it's happening so slowly that I really can't detect the temperature change there. If we look back at our aluminium in our copper sulfate solution, this one is warm, so it's exothermic. We can see a lot more of the copper has been deposited on the surface of the aluminium. Okay, we're now in the fume cupboard for test number 4 because we're using the concentrated hydrochloric acid. So we're doing it over here. We're going to generate some chlorine gas in this experiment, so we don't want to be inhaling large quantities of that. We're asked to put just a small amount of potassium permanganate into the test tube. It does say to use the end of a small spatula. So I'll grab my spatula that I was using before. And there's my permanganate in the bottom of the test tube. And now I'm going to add 3 to 4 drops of concentrated hydrochloric acid. Swap them over. Well, I can definitely see reactions occurring. It's warm. I've got browny sort of substance that is formed, which I reckon is a manganese oxide perhaps, or manganese. There were bubbles, the gas. So, yep, again, we've definitely had a chemical reaction occur there. I know, too, that if I have a quick sniff, that chlorine gas has been generated. And they are our little tests from experiment 1. But now it's important that I clean up my workstation. I'm going to pack away all of the reagents that I've used and empty the test tubes into the waste container. So I've now packed everything that I've used back into the relevant containers on the trolley, and now I'm going to empty out my waste. I've put the used straw into the bin. can actually get the piece of aluminium. See that we've got a lot of copper on there, but I can put this in the bin. This one. Now I'm going to give these test tubes a good rinse out. If there are any that are stained, then I'll put them in the container for Mandy to wash. Otherwise, they can just get left to air.